Okay, so here's how you would do the first problem. And since there's only three, I went ahead and made one that was um, similar, but not exactly the same. That way you could still get to practice. So what I was saying is that when you are solving these rational equations, it's really just the same thing you've been doing. The 6 is like over 1. So you have three denominators, and you need to still an LCD. So um, make our LCD, and you guys are all pretty good at this. We know we need an x, and then we know we need an x minus 1. So these are already factored. We don't need to factor to figure it out. So that's our LCD. Okay, so if I look at this first fraction, what's missing is the x minus 1, right? So we would have to take our 5, and we would need to, here, I'll just do it over here, and we would need to multiply it by x minus 1, right? The top and the bottom, but we don't really care about the bottom because we know they're all going to be this eventually. For the 4, we're missing the x, so I would need to multiply the top and the bottom by my x, just like I normally would. And then over here, this is new, but it still applies. It still needs the LCD, and we have a 1, so we're missing all of this. So I would need to multiply the 6 by the x and the x minus 1 for both the top and the bottom in order to make sure we have a common denominator. So I'm going to go ahead and multiply my numerators. So 5 times x is 5x, and then 5 times negative 1 is minus 5, right? Now I've got my plus, and notice I'm just ignoring the denominators because I know they're all going to work out to be x times x minus 1. Okay, so then with the 4, I'm going to multiply that by x, and then with the 6, that's a little more tricky. So I'm going to hold off on the 6, and I'm going to do x times x minus 1 first. So I'm going to get x squared minus x. Then I'm going to multiply that by 6, and then I'm going to get 6x squared minus 6x. Okay, so here's where you don't need to worry about the denominators, because if the denominators are all equal, then what makes our numerators all equal? So all I'm going to do is combine my like terms. 5x and 4x is 9x, and then I have a minus 5 here, and then it equals 6x squared minus 6x. I'm going to put everything on the same side because I'll have a quadratic. So what I'm going to do is I'm going to move the 9x over here to the right. So I'm going to subtract 9x, and I'm going to get negative 5 equals, so I'm basically just combining all my like terms at this point, and then I would need to move over the negative 5, so I would have to add 5 to both sides, and I would be left with 0 equals 6x squared minus 15x plus 5. Okay, and then I'm not going to do it, but from here you would just, to solve this for x, because it's a quadratic, remember we're going to get two factors, and we would just set each factor equal to 0. This is just quadratic grouping. So, you know, you'd make your x like you normally did. And I just made this problem up, so I'm not 100% sure that it would work, but remember that you would put 30 in the top, negative 15 here, then you would say what times what is 30, that adds to be negative 15. And then you would go ahead and you would just factor this using quadratic grouping. But I think the other ones come out a little bit nicer. Again, I just threw in some random numbers, so I don't know if this one works as well, but let me know if you still have questions, and especially as you get to the second one or the third one, or if you have any questions with the quadratic at the end. Remember, we always want to set it equal to 0. That's why I moved everything over to one side before you can solve it. And, you know, like when we actually put it into factors, we might get something like, you know, 3x minus 5 and 2x plus 1 or minus 1 or something like that, and we would just set each of those terms equal to 0. And I just made that up, so I don't know. All right, hope this helps, and but let me know if it doesn't, and I can definitely go through another one with you.